Good morning, students. Chapter 8, Gravitation. Yes, in last lecture, I think we discussed about gravitational potential energy. Okay. In this topic, we will see escape energy and escape speed. Now, what is meaning of escape? That you know. Okay. Yes. If I drop this chalk by itself, it will move towards Earth due to gravitational force of Earth. But by itself, it will not move in vertically upward direction, means away from Earth. To move this chalk away from Earth, we have to give some initial energy. Yes, we have to give some initial energy, we have to give some initial speed. Okay. If I throw this chalk, means if I give it some initial speed, due to that initial speed it will gain some kinetic energy. Due to that kinetic energy it will move in upward direction. Yes or no? Yes. Okay. So yes, if I throw, means if I give some initial speed to this chalk, it will move. Okay, up to some height, up to some maximum height, and then it falls back to Earth. Yes or no? Yes. Height attained by object depends on its initial speed. Yes. Height attained. Okay, height attained. Okay, what is the maximum height covered by object? It depends on initial speed. If speed is less, then height is less. Okay, if initial speed is greater, then yes, height is also greater. Yes or no? If you are given one ball, okay, then throw that ball in vertically upward direction with maximum speed you can throw. Okay, so yes, it will go up to maximum height according to that speed, and then it will fall back to Earth. So some questions arises. Okay, is it possible, okay, if we throw any object with such a speed, okay, it never returns on surface of Earth? Yes, it is possible. Yes, it is possible. Okay, see, right now we all are in gravitational field of Earth. Yes, we all are in gravitational field of Earth. Means we all are in binding of Earth. We are not free. We are in binding of Earth. So, to remove any object from gravitational field of Earth, that object is supplied some minimum amount of energy. That energy is called escape energy. That energy is given in form of kinetic energy, means we have to throw object. And with which speed we throw it, to remove it from gravitational field of Earth, is called escape speed. Okay, so first of all understand what is escape energy and what is escape speed. Again, we all are in binding of Earth, gravitational field of Earth. We are not free. Okay, if we want to remove any object from gravitational field of Earth, okay, then we have to give that object some minimum amount of energy, which is called escape energy, and that energy is given in the form of kinetic energy. Clear about this? Okay, so now what is escape energy, how to obtain equation, what is escape speed, that we will discuss in this session. Okay. So see, yes, we will start with one example. Okay, let object of mass m is lying on surface of Earth, and it is stationary. Let surface of Earth and it is stationary. So, kinetic energy of body object K is equal to 0. Okay, potential energy of object or body U is equal to, yes, we know that. See, object of mass m is lying on surface of Earth. So what is its potential energy? It is minus GMEM upon I. Yes or no? Yes. K is equal to 0. U is equal to, it is minus GMEM upon I. Clear about this? Okay. So therefore, total energy of body E is equal to, it is kinetic energy plus potential energy. So that total energy E is equal to, it is 0 minus GMEM upon I. So therefore E is equal to, it is minus GMEM upon I. See, this total energy is negative. This total energy is negative, means object is in binding with Earth. Okay, negative sign indicates body is in binding with Earth. Clear about this? Okay. So first of all, you are given any situation. Okay, it is one case actually. Okay, but if you are given any situation, first of all you have to find kinetic energy of system, then you have to find potential energy of system, then you have to find total energy of system. Total energy of system is equal to, it is minus GMEM upon I for this case. Okay. Now, if this body is supplied, see here I have to write, if body is supplied, if the body is supplied plus GMEM upon RE energy. If body is supplied plus GMEM upon RE energy extra, then what happens? Its initial total energy is minus GMEM upon RE. If the body is given plus GMEM upon RE energy extra, additional, then its total final energy becomes, initially it has GMEM upon RE energy. If we supply plus GMEM upon RE energy, okay, then what happens? Its total energy becomes 0. Its total energy becomes 0. It means what? It means object or body is escaped to infinite distance. Infinite distance means out of gravitational field, where its total energy, okay, where its total energy becomes 0, and therefore body is escaped to infinite distance means infinite distance, and infinite distance potential energy becomes 0. Its potential energy and kinetic kinetic energy becomes 0. Clear? But when again you are given one condition, you have to find total energy of object minus GMEM upon RE. If we supply the same amount of energy but positive, if we supply the same amount of energy but positive, okay, if body is supplied or body is given plus GMEM upon RE energy, then total final energy becomes 0, means object is escaped to infinite distance, means we can say object is removed out of gravitational field of Earth. Object is removed out of gravitational field of Earth, okay, where its total energy becomes 0, its potential energy and kinetic energy becomes 0. Clear about this? Okay, if body is given energy, if body is given energy greater than plus GMEM upon I, plus GMEM upon I, yes, it will be escaped from Earth to infinite distance, where its potential energy becomes 0, where its potential energy becomes 0, where its potential energy becomes 0, but it has some kinetic energy. It has some kinetic energy. Clear about this? But it has some kinetic energy. So see, what is meaning of this? See, if I have some object lying on surface of Earth and it is stationary, and if I find its total energy, for example, its total energy of object, total energy of object, E is equal to, it is minus 100 joule. For example, then case 1, if we supply energy, E is equal to plus 100 joule, exactly plus 100 joule, like this. If we supply plus 100 joule energy, then it is removed from field, gravitational field of Earth, okay, at infinite distance, where its kinetic energy is 0 as well as potential energy is 0. Simple. Okay, its total energy is minus 100 joule. Case 1, if we supply energy E is equal to 100 joule, okay, it is removed from field at infinite distance where K is equal to 0 and V is equal to 0. But if I say case 2, okay, if we supply energy which is E is equal to, okay, if we supply energy plus 150 joule, then what happens? See, total energy of object minus 100 joule, it means it needs only 100 joule energy. It needs only 100 joule energy, okay, to remove from gravitational field of Earth. Okay, it only requires 100 joule energy. Okay, by absorbing or by getting 100 joule energy, it is easily escaped from gravitational field of Earth. Remaining energy, see, out of 150 joule energy, 100 joule energy is used. 100 joule energy is used to remove from gravitational field of Earth, and another extra energy is as kinetic energy. Okay, so if we supply energy plus 150 joule, it is removed. It is removed from field. It is removed from field at infinite distance. At infinite distance. At infinite distance. Okay, where its potential energy is 0, but yes, kinetic energy is 50 joule. Kinetic energy is 50 joule, means the remaining energy is in form of kinetic energy. The remaining energy is in form of kinetic energy. So from this we can say that to remove any object from gravitational field of Earth, it is given some minimum amount of energy. See, here total energy of object is equal to minus 100 joule. So if we supply 100 joule energy, it is escape. If we supply 120 joule energy, it is escape. If we supply 150, 200, okay, whatever energy which is greater than 100, it will be escaped from gravitational field of Earth. But if we supply energy less than 100 joule, then it will not escape from gravitational field of Earth. Clear about this? Means this 100 joule is minimum energy that we have to supply. This 100 joule is minimum energy that we have to supply. We can supply more than 100 joule energy, but we cannot supply less than 100 joule energy to remove it from gravitational field of Earth. Clear? Okay? Okay, so yes, here from this all theory, we can now write one statement. Okay, the minimum amount of energy which is to be supplied to body to remove it from gravitational field of Earth is called escape energy. Okay, here I will write a statement. The minimum energy required to remove body from gravitational field of Earth is called the minimum energy required to remove body from gravitational field of Earth is called escape energy. Is called escape energy or binding energy Clear about this? Hello? Clear about this? Okay, so yes, it is escape energy. Now, what is equation of escape energy? See, minimum escape energy is this, minus gmem upon I. So now, it is escape energy. Now, what is escape speed? That we will see. Okay. Okay, see, what is minimum amount of energy required to remove object from surface of Earth which is stationary? It is, see, here for given case, escape energy E is equal to, it is escape energy E is equal to, it is plus GMEM upon I, because it is minimum energy that we have to supply to remove it from gravitational field of Earth. And see, this escape energy, okay, escape energy Here for given case, escape energy is equal to is given as kinetic energy. As kinetic energy. Yes, because we have to throw object. Hello. We have to throw object. Okay. So yes, this escape energy is equal to plus GMM upon RE is given as kinetic energy. Is given as kinetic energy. Kinetic energy means we have to throw. Throw means we have to give some speed. Okay. So the speed, initial speed to be given to body to remove it from gravity of earth is called the initial speed to be given to body to remove it from gravity of earth is called escape speed. It is denoted by VE, escape speed. VE, escape. Okay. So again, this escape energy is given in form of kinetic energy. Then how to write? Therefore, half mv square is equal to G n upon I. Clear? This energy is given form of kinetic energy. Half mv square is equal to G n upon I. Now m cut. So therefore, V square is equal to, it is 2G me upon I. Okay, so therefore, VE is equal to, it is under root 2G me upon I. It is equation of escape speed. Escape speed. But for object lying on surface of earth, stationary. Clear about this? Okay. So yes, this equation we have to remember. Now see, in this equation, I can modify this equation. How? See, VE is equal to under 2G me upon I. Yes. Now multiply I divided by. Then what happens? See, G me upon RE square. This G me upon RE square is nothing but gravitational acceleration on surface of Earth, GE. So I can write this equation as V is equal to under root 2GE I. So yes, this both equation you have to remember. Now see, 2, that is 2. GE, that is gravitational acceleration on surface of Earth, that is constant for each and every object. RE, that is radius of Earth. Or see in this equation, G 6167 into 10 to minus 11, m mass of Earth is given, R radius of Earth is also known. So if we put this all data and calculate escape speed, then VE you will get nearly equal to 11.2 kilometer per second. 11.2 kilometer per second. 11.2 kilometer per second. Clear? And see, 2G me upon I, 2Ge upon I, there is no mass of object in equation. No mass of object in equation. It means this escape speed is independent of mass. This escape speed is independent of mass of body. It means if you throw this chalk with initial speed 11.2 kilometer per second, okay, if you throw this bottle with initial speed 11.2 kilometer per second, or if you throw me okay, with initial speed 11.2 km per second, then these all objects, they all will be removed from gravitational field of Earth. Clear? Okay, yes, it is minimum speed. Okay, it is minimum speed. Okay, if initial speed of object is 11.2 km per second or greater, it is removed from field of Earth, clear? So yes, this point you have to remember. Okay, what is escape speed? Clear about this? Now see, this escape speed, this escape energy depends on given situation. Okay, we have derived these all equations for given situation. That is, object of mass m lying on surface of Earth and it is stationary. If it is moving, then yes, from the very first step, you have to calculate its kinetic energy also. Yes. Okay. So yes, it is escape speed, escape energy. Clear about this? Okay. For moon, yes, one additional data. For moon, that escape speed Vm is equal to, it is 2.3 km per second. For moon, escape speed is 2.3 km per second, which is 1/6 of this value. Okay, it means, see, what is reason? The moon has no atmosphere. Reason is this, escape speed. Okay, if speed of gas molecules is greater than 2.3 km per second, it is removed from gravitational field of moon. That's why it has no atmosphere. Okay, so yes, it is all about escape energy and escape speed that you have to remember. Clear? Okay, again, it is one special case. For different given situation, you have to obtain different equations. Okay, remember this value. It is one important MCQ. Escape speed of object on surface of Earth which is at rest. Okay, so yes, with this is it.